So today I'm going to talk about PredictionIO. So, so just introduce myself. I'm co-founder of PredictionIO, and currently I'm a product manager of the Salesforce Einstein. So today agenda, I will talk about what is PredictionIO, and I would, if time allows me, I will do a quick demo, and I will also share more lessons I've learned since I've joined Salesforce. So here I just give you a brief history of PredictionIO. So we founded the company in 2013 as an open source machine learning server framework. So our vision is to help companies to easily build real-world machine learning applications. So in 2016, we were bought by Salesforce, and now we are part of the Apache Incubator project. So in 2017, we are one of the top Scala open source project. So here, just give you a quick overview of PredictionIO, how this fits into the Salesforce Einstein. So PredictionIO is part of the App Cloud Einstein. So we offer PredictionIO on Heroku as a service. So it's an enterprise service. It provides a high-code solution for you to do the machine learning applications. So back in 2015, our vision is when we start PredictionIO, we asked the following questions, like why is web application development so popular? Like why mobile app application development is so popular? So why is it so difficult to build machine learning applications? How do we make it easier to make everyone can build machine learning applications and integrate the AI intelligence into the apps? So in the lab, when you do a machine learning, that's what you do. Like you write some code in the lab. You just write read the training data. You train a model, and then you make a prediction. That's how you do you can do ad hoc machine learning flow like this. But then when you go to the production, actually there's a lot of things you need to consider. Like how do you retrain the model based on the new data? How do you deploy a model to serve a real-time query? How do you monitor the model? So there's a lot of stuff to consider when you deploy machine learning into the real-world applications. So if you look at today's machine learning stacks, so basically we have to build machine learning. Okay, you need to have underlying. You have a data layer to get all the data, and then you have a processing layer to process the data, to do the machine learning training, to train a model. And then you have different kind of algorithms, libraries that you can use on this processing layer. And then on the higher layers, you have the API, the app layer that serve the machine learning model. So PredictionIO is like a framework that helps you to integrate all these pieces together so that you can focus on your business logic instead of doing all the integration works. So PredictionIO basically is built on top of this technology. It's built on top of Spark, and we support HBase Postgres as the data store layer. And then we provide an API, then you can build different kinds of machine learning engines on PredictionIO, and then you can deploy the engine and then integrate it into your applications. So this is a high-level overview of PredictionIO architecture. So basically, we have an event server that collect the events from your app. And then you can create your own PredictionIO engine that take the data from the event server. And the engine can take the real-time query from your apps and then generate the predicted results based on your engine, based on your model. So I want to talk about the abstraction. This is a very simple abstraction of the engine or PredictionIO, but actually, it's very powerful because it fits to how you apply. When you think about how you use machine learning in a real-world application, that's how you think about the problem. So basically, we have events, query, and predicted results. So for example, let's say you want to do a video recommendation. Your events basically is your user viewing behavior. They view this video, they look at that video. And your query, basically, you're asking, give me the top 5 videos for this user. Then the predicted result is basically the top 5 video IDs. Another example is for example, lead scoring. Let's say you want to predict how likely someone will sign up my web service. Then your events is your like browsing behavior, the device info. And then your query is like you're asking the question, how likely this visitor will sign up my service? Then the predicted result is like the probability that this visitor will sign up the service. Similar for spam detection. So the events data basically is a very simple structure that allow you to model it for different kind of applications. Basically, it's like events, entity type, who performed the events, what kind of events it, and the time of the event. And you can also add additional optional like properties to describe the events, like maybe the user buy the item and the price is like $5. Then you can add it as a properties of the events. So we have the events. The event data is collected to the event server, and then the engine can take the event data to train a model, and then use the model to do the prediction. So I will talk more about the engine. So if you look at today's, you think about like what's the machine learning process, basically you follow these steps, right? You read the data from the sources, and then you read the training data from the sources, different kind of data sources, and then you prepare data for the training purpose, and then you train a model using the training data. And then once you get a model, given the query, you use the model to make a prediction. And then with the prediction, you serve the prediction results back to the applications. And then to evaluate the model, basically you are comparing the predicted result with the actual result. So the way we abstract it is we call a DASE framework. So basically we have data source component, data preparator component, and the algorithm components to take care for each step, like serving components and evaluator components to take care of each of the functions. And then the DASE basically is the components that construct the engine as a PredictionIO engine. So this is a more detailed view of the engine. Basically, it's like we have data source component to prepare the training data, and then you fit to the data preparator to prepare data for the training purpose. And then the prepared data can fit into the multiple algorithms. Which each one can train their own model. And this is the first phase, the training phase. The next phase is the journey to serve the prediction. So basically, the algorithm would take each model and then take the input query from the applications. Each algorithm will use the model to generate the predicted result and then combine as a serving. Combine the result to the serving layer, and then the serving layer could serve the final predicted result back to the applications. So this is the architecture view. So basically, PredictionIO offers you the event server to collect the event from your mobile web server or app server. Then the data offline will fit into the engine training process to train a model. You can use Spark ML to train a model. And then the engine can get the model and deploy as a prediction server. The prediction server will basically serve the real-time query and return the predicted result. At the same time, you can also retrieve the real-time data from the events to make the prediction. For example, you can, based on the recent user history, to generate your features in the real time and then combine with the model and then generate the predicted result. So PredictionIO offers different kind of engine templates to help you to bootstrap your machine learning applications. So there are different kinds of engine templates. We have lead scoring, we have recommendation, or similar products, or we have a universal recommender. So these are contributed by many contributors and also some of the official templates we offer to help you. Let's say you are doing recommendation, you can just download the recommendation templates and then you can start building integrate it into your application right away. So actually, to use PredictionIO is actually very easy. You just build an engine, train a model, and then deploy it. Basically, 3 command line. You can deploy machine learning application and then integrate it into your application. Let me see if I have enough time to show you. I can show you a quick demo to kind of illustrate what I'm talking about. So first, I will start all the prediction. Okay, first I will start the PredictionIO server. So basically, you will bring up the event server, and that can collect the events. And then here I use the text classification as an example template. So basically, this demo I will show you to use the text classification that you can predict how likely this email is a spam or not spam. So let me show you the code. This is the template, the text classification template. I'm not sure. Can you see the? Is it too small? So here you can see basically this is a text classification engine. It consists of data source, preparator, algorithm, and a serving layer. The algorithm we use Spark ML. Basically, the algorithm basically is take the text data and then do the TF-IDF transformation, tokenize it, and then use the naive-Bayes to train a model. Naive-Bayes algorithm to train a model. And then there's the engine.json. Basically, it specifies the parameters to the engine. So you can easily change the different parameters when you train the engine. For example, this is to define how many features generated for the text. So to train an engine, basically, you do PL train. Oh. Sorry, go in the wrong direction. So basically, you kick off the training, you kick off a Spark job and then start the training process. In the meantime, I'll show you the. So these are all the events I have already imported to the event server. Here you can see the text, the subject, and then the label is a spam or not spam. And when I kick off the PL train, basically you take all the events data and then train the model. And you can see the model is trained successfully. Then I can deploy it. So once I deploy the engine, basically it's a real-time server that can respond to a real-time query. And I can also go to this page to look at the status of the engine. So this gives you the information of the engine being deployed, like the ID and also the parameters of the data preparator, data source, and algorithms. Actually, this is a logistic regression algorithm. So let me show you this real-time query. For example, so after I run the PL deploy, basically there's a server running in the port 8000. Then I can send a real-time query to the server to predict how likely is this a spam or not, like earn extra cash. So you can see your response real-time predicted results, spam, confident, you give you the confidence 0.7. And you can also change different engine parameters, and then you can create different engine variant, and then you can deploy multiple engines onto different ports, and then you can have actually you can do A/B testing of different engines as well. Then you can in a real life application you can do like A/B testing, so you can route the traffic to the engine 1 and engine 2, and then you can compare the results as well. So I want to share a bit more lessons I've learned since we started PredictionIO. So one of the problems of the data science or machine learning is how to translate a business problem to a machine learning problems. So very often it's not about choosing the right algorithms. It's more about like the feature engineering part, what features you should use to solve your problems. And how to know, to do that, actually require lots of domain knowledge and lots of iterations. And also, how to test a machine learning application is a challenge, because think about this, if let's say, for example, if I tell you the spam this is not a spam and I give you the confidence, but how do you know this is not a bug? I mean, how do you know this is right or wrong? Because it could be a bug there that affect the performance, or just because of the model. So how to test the functionality is a challenge. And also the model quality is how do you guarantee every time you deploy a new model, the model performs at least satisfy certain criteria before you use the model. And also you need to think about how to do the business metrics or performance metrics. How do you measure, let's say you do a recommendation, video recommendation. How do you measure the effect, the performance of your recommendation? So you need to get a user feedback, and then you need to do some kind of offline metrics to analyze did the user actually click my recommendation? And there are also more things you need to think about is the monitoring, like how do you monitor the whole system, and how do you manage all the different kinds of models for each kind of applications. So PredictionIO is open source, so you feel free to try it out and join our community. And Salesforce also has a good trailhead program to help you to understand data science and AI. Any questions? Yeah, so PredictionIO is a framework, the DASE framework. Then you can use different kinds of library to do feature engineering. Like in our example, we use Spark ML to do the TF-IDF transformation. So basically, it's up to the developer to customize what they want to use. But we provide a framework to integrate the whole stack, like the data layer to collect all the events, and then integrate with the Spark, and then you can also deploy as a service to serve real-time query. Yeah, I'm not expert of deep learning, so my understanding is, so basically you can use deep learning to create, they call it embeddings. So basically it's some kind of latent features that, I mean, conceptually you can use neural network to generate features for image, and then use this feature to downstream modeling purpose. I'm not expert in it, so that's the best I can answer. Okay, thank you.